all the previous chapter 8. So if you have any questions from previous chapter, you may go ahead. And in case there is no question, let me start this chapter of hypothesis testing. Let us go directly towards the meaning of this hypothesis testing. What is hypothesis?
An assumption.
An assumption, or we'll say a statement about any unknown population parameter. For example, mu is 7. So that is an assumption about mu. We don't know what is mu. So giving a statement regarding mu, that is a hypothesis. Or mu greater than 7. That's also, I'm saying something about the unknown population parameter mu. So that is another hypothesis. Mu greater than or equal to 7. That's also hypothesis. P less than or equal to 0.5. The population proportion, P is another parameter. Population proportion is less than 0.5. That's a hypothesis. P is not equal to 0.7. That's also hypothesis. Sigma square is greater than or equal to 10. That's also hypothesis. So there are many possible hypotheses I can write here regarding population parameters, any population parameter, whether it's mu, we have talked about mu, we have talked about sigma, we have talked about population proportion P. These are the three parameters we have talked about. Whereas if I write this x bar greater than 7, this is not a hypothesis, because this is not a statement about population parameter. This is about x bar. This is not a hypothesis. Similarly, if I write p hat less than or equal to 0.5, that is not a hypothesis. So the meaning of this word hypothesis is that it is a statement, it is an assumption about the unknown population parameter. And specifically, we'll be interested in mu. I'll start with mu as my population parameter of interest. So the first thing we will do is we will formulate the hypothesis about mu, and once the hypothesis is formulated, then we will check if this hypothesis is true or not. So the procedure, the whole procedure that we follow to test if this hypothesis is true or not, that procedure is called hypothesis testing. So I would say hypothesis testing is a procedure or a set of steps that we follow to check if the formulated hypothesis is true or not. So the first thing we will do is we will formulate the hypothesis. Once a set of hypotheses is formulated regarding any parameter where you are interested, for example, the question is about the average, so your interest is mu. If the question is about proportion, your interest is p. So the first thing you will do is you will formulate the hypothesis, then you will follow a number of steps to check if your formulated hypothesis is true or not. And finally, based on your decision, you will make conclusions whether your hypothesis was true or not. So we start with the testing hypothesis about mu. And we start with the simple case when sigma is known. If you remember, we had this similar case in chapter 8 when sigma was known. We used a confidence interval based on Z distribution. And when sigma was unknown, we looked into the T table. That is because when sigma is unknown, the distribution of x bar minus mu over S over square root of n, that follows a T distribution. I will discuss that second case later when sigma is unknown. And then obviously there is a limitation of T table, that not all the degrees of freedom are available in the T table. So if the degree of freedom is large, you borrow the degree of freedom from Z table. You borrow the critical value from the Z table. All the other calculations, they remain same. You just pick the critical value from the Z table. We'll do the same in here, but I'll start with the simple case here. I'll start with testing hypothesis when sigma is known. So in question, we can give you three different types of hypotheses, three different sets of hypotheses to test. We can give you a hypothesis to test that mu is equal to something against the opposite. We can give you the question to test mu greater than or equal to something against the opposite. Or we can give you a question to test mu less than equal to something against the opposite, that mu is greater than something. This something will come from the question. This is the something. This will be a number. For example, I ask you to test that the average score in STAT 319 is 70. So you will be testing mu equals 70. And then you will formulate the opposite, the alternative hypothesis, that is H1, that is mu is not 70. I will talk about this one later. Once you figure out which of these sets of hypotheses is true for your question, and only one of these three will be true for your question, you should know that the first one is an example of two-sided, and these two are one-sided. Where you see a greater than sign or less than sign in H1, these are one-sided hypothesis. And where you see not equal to sign in H1, that is a two-sided hypothesis. I will talk about this one also. The second thing you need from question is the value of alpha. It will be either given or assumed what?
95.
Assumed 5%, 90 against 95. So it will either be given in the question or you will assume it 5%. The third thing is the formula that you will use to test this hypothesis. That formula is called test statistic. And we are very well aware of what test statistic we are going to use. We are going to use this Z. The fourth step will be to make the decision. And to make the decision, the rule will depend upon your H1, the alternative hypothesis. Whether your H1 is not equal to or less than or greater than, the rule depends upon the sign. So I would say I will reject H0. We reject H0 if. Now after if, it depends upon what is the sign of your H1. So if your H1 is not equal to, you will reject H0 if your calculated value of Z absolute value is greater than the critical value that will come from the Z table. And you already know how to get this Z alpha by 2. We did this in confidence intervals. If your alternative hypothesis is less than, you will reject H0 if your Z0 is less than minus Z alpha. I'll talk about how to get this value from the table. And you will reject H0 if your H0, H1 is greater than, your rejection region will also be greater than. And finally, when you have your decision, whether you go with H0 or you go with H1, you will make conclusions accordingly. This whole procedure that you see on your screen, this procedure is called hypothesis testing procedure for mu when sigma is unknown. And the approach we are using here is the rejection region approach. There is another very popular approach which is called p-value approach. We will talk about that one later. That is more popular than this rejection region, but both of these two approaches always they give you the same result. So this whole procedure, this is called hypothesis testing procedure for testing the population mean when sigma is unknown. Obviously, mu is what? Mu is the population mean. So you have a numerical population on a variable x. It has a density function. We assume it to be closely normal, and then it has a unknown mu and known sigma. The information we need from the question is what? The information we need from the question is regarding X bar. We need X bar from the question. It will be given somehow. Either directly X bar will be given, or the sample will be given and you will be supposed to calculate the mean from the sample. We need to see from the question what is the value of mu that we want to test. That will be given in the question somehow. Sigma will be given in the question somehow. N will be given in the question somehow. This sign of H0 and H1 will be given in the question somehow. So these are all the pieces of information. This alpha will be given in the question or assumed 5%. And the remaining things are as it is that you see on your screen. Now, from this whole thing that you see on your screen, this is the only part that will be given to you in the formula sheet. The one I just circled with the black color. The test statistic. Other than this, nothing will be given in the formula sheet. Now, an obvious question is, how do you memorize these rules? How do you memorize these rules? The answer is you don't need to memorize. They are directly coming from the sign of H1, the alternative hypothesis, and I will let you know how to judge what should be the rejection region. So these are not something that you have to memorize. These are something you have to understand how they are coming from H1. So I'll talk about this one later. For now, I'll jump on to the question, a question where we will test the hypothesis regarding mu. And there I will explain how to formulate H0 and H1. Whereas H0 is called null hypothesis. And H1 is called alternative hypothesis. Sometimes in question or in literature, you will see the word hypothesis with spellings SES. Who can tell me what does this mean?
Is this the plural?
It is the plural of hypothesis. So if you are talking about more than one hypothesis, you'll see the word hypothesis with SES. Now we got a misconception that whatever statement is given in the question, that is H0, which is not true. That is a misconception. I'll tell you a procedure that works 100% of the times. How to formulate H0 and H1 from the question. You must follow this procedure. And this procedure works 100% of the times. Let us go to that procedure with reference to an example. Let us say we have this example. Now in this example, the question says that the life in hours of light bulbs is normally distributed with standard deviation. Now here we're talking about the distribution, and when something is attached with the distribution is population. So the word standard deviation here is your population standard deviation. This is sigma, not the sample standard deviation. If the word standard deviation was attached with this sample, then you would say it's S. So all the things I highlighted in the green color, these are from sample. That means your N is 20, your N is 20, and your X bar is 1014. If the statement was that a random sample of 20 bulbs has a mean of 1014 and a standard deviation of 25, you would say that standard deviation is S. But here the standard deviation, the word standard deviation is attached with the distribution, and the distribution is basically the population. It's a model of population. Read the question. The question says at 5% level of significance. So the first thing that is given in the question is your alpha. It is 5%. Alpha is called the significance level. 1 minus alpha is called confidence level. At 5% significance level, is there evidence to support the claim? And what is the claim? I'm going to highlight the claim now. Is there evidence to support the claim that the bulb life exceeds 1000 hours? Now I'm going to tell you the steps to formulate H0 and H1, and this is the most important part of hypothesis testing. Formulating H0 and H1 is the most important and most critical step of hypothesis testing. The first thing you need to identify is what is your parameter of interest? Are you interested here in the average or the proportion? And the answer is you are interested here in the average, not the proportion. So in your syllabus, there are two parameters of interest that you will be interested in, either mu or p, like the confidence interval. So the parameter of interest here is, I'll write it here, parameter of interest is mu. You're talking about the average bulb life. Now you read the statement. What do you want to test? I highlighted the statement with this blue color, with this dim blue color. Let me use, let us say, red color for this one. This is the statement I want to test. Number one, read the statement. That is to be tested and write it in terms of notation. So if I want to write this red thing in notation, what can I write? Raise your hand if you can tell me if I can, if I want to write this red thing in terms of notation. What is the notation for this red thing, red statement? Amjad Ammar.
H0 bigger than 1000.
H0 or mean mu?
Oh yeah, mu.
Mu. Forget about H0. It's about mu. So the statement is that mu exceeds 1000. Exceeds does not contain an equal sign. Be careful. The statement is that mu greater than 1000. That's the statement of the question. I'll write in bracket. This is my question or claim. So this is your step number one. Your claim may contain equal sign, may not contain equal sign, not necessarily. I can say that bulb life is at least 1000. So in that case, it will be greater than or equal to 1000. I can say bulb life is 1000. So in that case, it will be equal to 1000. I can say bulb life is not 1000. In that case, it will be not equal to 1000. So your statement can be any of the six possible hypotheses I wrote here. Any of the six. It can be mu equal to 1000, not equal to 1000, greater than equal to 1000, less than 1000, less than equal to 1000, greater than 1000. Any of these six. So your question will be one of these six statements. Once you have the question in terms of notation, second step is to write down the opposite hypothesis. That is, in this case, my opposite hypothesis mu greater than 1000, the opposite is what?
less than or equal 1000.
Less than or equal to 1000. Now you have your two hypotheses. One is your question, the other is the opposite. Now, out of those two hypotheses, one of them will always contain equal sign and the other one will not contain equal sign. So the step number 3 is to finalize H0 and H1. The one with equal sign is H0 and the other one is H1. So now you are able to write that H0 is mu less than or equal to 1000 and H1 is mu greater than 1000. And for the reference, at the last step when you will be making conclusions, you should know which one is the claim. So for your convenience, I'm writing here that this is the claim. This will help you at the last step when you will be making conclusions after the decision. This will help you that what was H0 and what was H1. H1 is basically the claim and opposite hypothesis that you defined yourself, that is H0. You will always follow this 3-step procedure to make H0 and H1. Number 1, you will read the claim and write down the claim in terms of notation. The claim will be one of the 6 statements. Number 2, you will write down the opposite. The opposite will may contain equal, may not contain equal, depending upon whether the actual statement contains equal sign or not. And number 3, you will see which hypothesis contains equal sign and which one does not contain equal sign. The one with equal sign is your H0, the one without equal sign is H1. Let me solve this question completely and then I will give you some more examples of different questions from where we will make H0 and H1, because this is a very critical step, making H0 and H1. So we are done with step number 1. Let's go back to the procedure. Step number 1 is what? You have to make H0 and H1. Once you are done with step number 1, you go to step number 2. You look for alpha, level of significance or level of confidence. So this alpha is either given or assumed. So in our question, it is given to be 0.05. So we'll write that one. Alpha is given as 0.05. The third step is the test statistic. This formula will be given in the formula sheet. Z, which is X bar minus the value of mu you are testing divided by sigma over root of n. So plug in the values and get the value of test statistic. Your X bar from the question is what? 1014. 1014 minus what is the value of mu you are testing under H0? 1000. So mu naught is 1000 divided by what is sigma? I think sigma was 5. What was sigma? 25. So sigma is 25 over n was what? Sample size was where is the sample size?
20.
20. N is 20. So you'll plug in the values and you will get this this test statistic 1014 minus what is the final answer? That's it. 0 4 4. That's it. 4 4 4. That is your Z. Once you have Z, now we go to the last step. And the last step is to write down the rejection region. And for your case, you, I think, are in the last case here. You're dealing with this one where your H1 is greater than. So the rejection region comes from the sign of H1. When H1 is greater than, the rejection region is also greater than. When H1 is less than, rejection region is also less than. And when H1 is two-sided, not equal to, the rejection region is also two-sided. I will show you this fact later, that this absolute value is basically two-sided. So your rejection region here, for this case, when your H1 is greater than, your rejection region is reject H0 if Z0, which is 2.5044, is greater than Z alpha. Now we have to look for this value in the Z table, where Z alpha is equal to what? You will look for alpha is 0.05. You will look for 1 minus alpha in the table, and you will not divide alpha by 2 because your H1 is one-sided. If it was two-sided, you would divide it by 2. In whole chapter 8, we were making two-sided confidence intervals. So we always used to divide alpha by 2. Here it depends if your H1 is one-sided or two-sided. If it is one-sided, you will not divide it by 2. If it is two-sided, then you will divide it by 2. If you look at the rejection regions I wrote, look at them. Here I wrote Z alpha by 2, whereas here I wrote Z alpha. Also here I wrote Z alpha. So I'm not dividing it by 2 when my H1s are one-sided. So I'll go to the Z table and I look for 1 minus alpha, which is 0.95. I look for 0.95 in the Z table, and my corresponding value will be my critical value. So let us go back to Z table.
Excuse me, doctor.
Yes.
It is one-sided, but which one?
It's the upper sided.
The last one?
The last one, yeah, it was the last one.
Okay.
In any case, your critical value of Z will be positive. Either you are in the middle case or the last case. I'll let you know. Okay, let us try and find 0.95 inside the table. Are you able to find 0.95 in the table?
1.6.
So it is somewhere around 1.6 something. I found 0.9495 and I found 0.9505. 0.95 is right in the middle. So the critical value I will take what?
1.645.
1.645 is the best thing I should do. But in exam, if you take 1.64, it will not be wrong. If you take 1.65, it will not be wrong. Other than 1.64 or 1.65 or anything in between 1.64 and 65, that will be wrong. So anything between 1.64 and 1.65 for this specific value of alpha will be acceptable. So the best thing I'll do, the best thing here, I'll take Z alpha by 2 equals 1.645. So I took my critical value from the Z table, and when your H1 is positive, it's greater than the critical value will be positive. When your H1 is less than, your critical value will be negative. I'll talk about the negative later. So now your rejection region is you reject H0 if your Z is greater than 1.645 and your Z is 2.5 something. Is it greater than 1.645?
Yes.
Yes, so this is the time you make your final decision. As your Z is greater than 1.645, so we reject H0. If you fall in the rejection region, you will reject H0. And once you reject H0, now is the time to make conclusion. This is where I told you that writing down which one is the claim, this will help. Which one is the claim? Your H1 is the claim. As you as you rejected H0, that means you are going with H1. That means your H1 is true. So you will say your claim in the question is true. What was the claim? The claim is that the bulb life exceeds 1000 hours. So you will say that the average bulb life exceeds 1000 hours. This claim is actually true. This completes the solution.
If we reject, it became true.
We reject what?
If we reject the claim, it became true.
If you reject the claim, you will say the claim is not true.
Yeah, if we reject Z naught.
You are
It will
rejecting
become-
Z naught here. You are rejecting Z naught here.
So it will be true. The conclusion.
I'll give you an example. Suppose your X bar was 1004 instead of 1014. Suppose it was 1004. And you were testing the same question, exactly the same question. In that case, your Z will be what? 1004 minus 1000 divided by 25 over root of 20. What do you get? Calculator. 0.715. 0.7155. Now here again, if I use the same alpha, if I use alpha 0.05, I will reject H0. If my Z naught is if my Z is greater than 1.645. Now in this case, is it greater than 1.645? No. So your decision will be, as Z is not greater than 1.645. So we fail to reject H0. That is the decision, and the conclusion will be, we conclude that the claim is not true. The claim is not true. Is that clear? Someone who asked the question, I did not get if this was the question. Yes?
Yes. No, I understand.
Let us practice making H0 and H1 for different statements. What if you were testing, test the claim that average lifetime does not exceed 1000. The question previously was that the average lifetime exceeds 1000. Now I'm saying test the claim that it does not exceed 1000. What will be your H0, H1? Same procedure. Let us follow the procedure instead of directly writing H0, H1. Let us follow the procedure. What is the statement in terms of notation? Mu does not exceed 1000. Mu does not exceed 1000. How can you write this in terms of notation?
It is mu less than or equal 1000.
Less than or equal to 1000. Write down the opposite.
Mu bigger.
Bigger than. Now you have two statements. One of them contains equal sign. One of them does not contain equal sign. The one with equal sign is your H0. The one without equal sign is your H1. And guess what? These are the same hypothesis. Where is the difference? The difference is only here that now this is your claim. In the previous question, H1 was your claim. So the difference will come when you are concluding in the final step.
So H0 is always the claim.
No, in this question, the one you just solved here, H1 was the claim. Here, look at this.
Yes.
The one you just solved, H1 was the claim. So I gave you the opposite example immediately. Here, H0 is the claim. Yes, Muhammad Faris.
Doctor, can he say the average lifetime exceeded by 1,000 hours?
No, I will not say that.
Okay.
I can understand this exceed and exceeded by is disturbing all of you. Okay, assume you got the same data for this question and assume you got same z equals let's say 2 point, what was that? 2.5044. 5044. Let us say I got for this I got same x bar equals 1014. Your n was 20. Your sigma was 25. So let us say this was the data for this question. Your z was 2.5044 and assume alpha to be 5%. Your rejection region is reject H0 if z is greater than 1.645. Because H1 still have the greater than sign, so I'll write greater than 1.645, and I'll again reject H0 here as Z0 is greater than 1.645, so we reject H0. Now the difference will come. Now you rejected H0. This is where the difference is. Now your H0 was the claim, so you rejected your claim. So you will say the claim is not true. In the previous question, your H1 was the claim. So the difference was at the final stage. Now at the final stage, you will say that we conclude that the claim of mean lifetime not exceeding 1,000 hours is not true. Previously, it was true. Oh, yeah, here it was true. Another example.
Excuse
Yes.
me, Doctor.
Yes,
How
Muhammad.
do we? I am Abdulal.
Yes, Ahmed.
How do we get 1.645?
How do we get 1.645? Step number
From
one.
the zero.
From the z table.
Zero.
Step number 1, look for alpha. Step number 2, look for 1 minus alpha. Step number 3, look for this 0.95 inside the z table, and the corresponding value of z is your 1.645.
Okay.
Muhammad Ali.
Doctor, can you go with the previous question? First question.
The green color?
Your first question yourself.
I'm not able to hear you properly. Can you say it again?
Can you go to the first question?
First question. I'm here at the first question.
Yes. What if O was not rejected?
What if H0 was not rejected? Here is the case where I was unable to reject H0.
It will be.
I will go with H0. If it is not rejected, I will go with H0. I will say my H0 is true.
Okay.
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 Then I will conclude according to whether my H0 is the claim or H1 is the claim. The conclusion will depend upon which one is the claim.
Okay, I got it.
Let's do one more example. Test that the average lifetime is 1000 hours. What is the statement?
mu
Is
equal
equal.
1000.
Mu
Equal.
equals 1000. The opposite mu not equals 1000. The one containing equal sign is H0. The one without equal sign is H1. And just for making it easy for you to make the conclusion, I will write H0 is basically the claim. It is basically the question. It's not necessary to write, but this is only for your help for the last step. Let's say I use a value of alpha to be 5%. And let us say I have the same data from the question. My X bar is 1014, my N is 20, my sigma is 25. So in that case, my Z will be 1014 minus 1000 divided by 25 over root of 20. That was 2.0544. Now the difference will come. You have a two-sided H1. So for the two-sided H1, you will get the critical value like you will write alpha, that is 0.05. Alpha by 2 will be 0.025. 1 minus alpha by 2 will be 0.975. Look for this 0.975 in the Z table now, not 0.95. You will look for 0.975 in the Z table, and the corresponding value is Z alpha by 2. That is?
Doctor?
Z is
2044.
5044.
5044. Thank
Yeah.
you. So this time your critical value will change because your H1 was two-sided. So you will look for 1 minus alpha by 2, not 1 minus alpha. So you look for 0.975 and the corresponding value of Z is 1.96. I will give you an overview of this one once again, how I looked for this value. I go to the Z table and I look for 0.975 inside the table. And I get it exactly. Luckily, I get it exactly. And the corresponding value of Z is what? The very popular value of Z, that is 1.96. So I get Z alpha by 2 equals 1.96. Now my rejection region is what? Reject H0 if Z absolute value is greater than 1.96. What is my absolute value of Z? It's absolute of 2.5044. That will be
less than.
As Z absolute, and this is Z absolute is 2.5044, as it is greater than 1.96. Is it greater than 1.96 or no?
Yes.
Yes.
It is greater than 1.96. So we reject H0. Once you have rejected, go back here. When you reject H0, that means this hypothesis is true. That means your claim is not true. You are going with H1. That means your claim is not true. Conclude that the average lifetime is significantly different from 1000, or it is not 1000.
It is confusing, the conclusion.
The conclusion is confusing. You just don't get confused. You see what is the decision. Once you see the decision, the first thing you try to see whether the decision is to go with H0 or against the H0. Here, what is the decision? You go with H0 or against H0?
Against, I think.
Against H naught. So when you go against H naught, that means you're going with H1, right?
Yes.
Now, as you're going with H1, is H1 your claim or no?
No.
No, so you're going against the claim. Go back here. In the previous question, what was your decision? As Z naught is this, we reject H naught. Did you go with H naught or H1?
H1.
H1, go back. Is H1 your claim or not?
No.
No, so you go against the claim.
Okay.
Go back to this question. As Z is not greater than 1.645, we fail to reject H naught. You fail to reject H naught and you go with H naught. Go with H naught. Here you go with H naught. Go back to H naught H1. Where is H naught H1? Here is H naught H1. You are going with H naught. Is H naught your claim?
No.
You are going against the claim. Come to this question. The first one we solved. We said as Z is greater than 1.645, we reject H naught. When you reject H naught, go with what?
What claim?
Go with H1. Forget about the claim. You're going with H1, number one. Now go back to H naught H1. Is H1 your claim?
Yes.
Go with the claim.
Doctor, when we reject and when we fail the reject.
When your value of Z, which in your case is 2.5044, when it falls in the rejection region, you reject. When it does not fall in the rejection region, you don't reject. And the rejection region is given here. Where is it? This is the rejection region. This is the rejection region for every case.
So we have 3 regions.
For 3 different questions, we have different regions. If your H1 is bigger than, you will follow this last one. If your H1 is less than, you will follow the middle one. If your H1 is not equal to, you'll follow the first one.
Okay.
Let us have another question for the less than. We have 6 minutes, so let us go with one of the questions for less than. I'll deliberately formulate a question. Test that the average lifetime is less than 1000 hours. Let's formulate H0 and H1 first. What is the statement? Mu less than 1000. That's claim. What is the opposite? Mu greater than or equal to 1000. Which one contains equal sign? First one.
H1.
The one without equal sign is H1. Second thing, let us try to write alpha. Let us say it is 0.05. So the critical value Z alpha is 1.645. Keep in mind the critical value will always be positive. And then in the formula, you will see a negative sign here. In the formula, you will see a negative sign here. When your H1 is less than, your rejection region should be in the negative side. So one of the common mistakes I see here is the students take Z alpha to be minus 1.645 and then they multiply it by minus again and make it plus. No, the Z alpha by 2 itself will be 1.645 and after multiplying it by minus, it will become minus 1.645. So the overall rejection region for the less than should be on the negative side. So when you are writing your rejection region here for the less than question, it should be reject H0. I'll write it here in advance. Reject H0 if Z is less than minus 1.645. The final rejection region should be negative. Now let us calculate the value of Z, assuming my information is N is 20, Sigma is 25. X bar is, let us say, 1020. What was it? 1014. So my Z will be 1014 minus 1000 over 25 divided by root of 20, 2.5044. Is 2.5 less than minus 1.645?
No.
No, so you will say as Z is not less than minus 1.645, so we do not reject H0. When you do not reject H0, you go with H0. And because you are going with H0, that means you are going with this hypothesis. That means the claim is not true. The average lifetime is not less than 1000. You are going against the claim. Going against the claim. Yes, any questions?
It's clear, Doctor.
Okay, next class I will talk about the second approach of testing hypothesis. We have actually three approaches. The first approach is called rejection region approach. This is the approach we have followed throughout today for all the 4 or 5 or 6 questions I solved. The second approach, and that is more popular approach, you will see in most statistical softwares and everywhere you'll see the p-value. That second approach is called the p-value approach. You will get to the same conclusion with that approach also, but there the procedure is slightly different. We don't look for the rejection region. Once we calculate the value of Z, the fourth step is to find the p-value instead of going to the rejection region. We find the p-value and then we compare the p-value with alpha. So that is slightly different from this procedure. Next class, which will be after the midterm exam. I'm not talking about the class actually. Next class on chapter 9 will be after the midterm exam. I'll talk about that after the midterm exam, and that will be the p-value approach for testing hypothesis. So I will stop with chapter 9 here. No more new material from now on. In the next class, which we have on coming Saturday, we will have a quiz on chapter 2. So in first 20-25 minutes, maximum 30 minutes, I would say 25 minutes. In first 25 minutes, I will be available for any questions you have, any queries you have. I will answer to those queries. And in the final 30 minutes, we will have the quiz in the class. If you have any question from today's class, you are most welcome to ask. If you don't have a question, you can leave the session now.
Thank you, Doctor.
Welcome.